everyone, it's your SI leader Noora here to talk to you about a quick hydrohalogenation problem. We're going to be discussing regioselectivity and the idea of carbocation stability, hyperconjugation, and Markovnikov addition across a double bond. So we have an alkene species over here, and we're reacting it with our hydrohalogen, our hydrochloric acid. So our double bond will function as our nucleophile. It is electron rich, and this pi bond region can come out here and pick up this hydrogen atom. Now the electron region of the covalent bond between the hydrogen and the chloride will pop off onto chloride, and that will give us two possibilities for our carbocation intermediate. Let me draw those two possibilities for you real quick. Again, we still have our methyl up here. And in this case, I added my hydrogen over here across the double bond, versus on this molecule, the hydrogen was added over here. And again, the methyl is still there. Now, this brings us to the idea of carbocation stability. So Markovnikov regioselectivity basically states that the reaction will proceed through the most stable cation intermediate species. Now, which one of these is more stable? Looking over here, we have a carbon or a carbocation that's attached to two other carbon molecules, atoms. So this would be a 2' or a secondary carbon, versus this carbon, which is attached to 1, 2, 3 different carbon atoms. So this would be considered a tertiary or a 3' carbocation. And as I've written up here, 3' is more stable than 2', which is more stable than a primary carbocation, which is more stable than a positive charge just on a methyl. And the reason for this comes back to the idea of hyperconjugation. So when you have a positive charge, you have an empty p orbital, basically, on your carbocation. And that empty p orbital can be stabilized through neighboring alkyl groups. So if you have a neighboring CC bond or a neighboring CH bond, it could provide greater stability for that positive charge. And that is why a 3' system is more hyperconjugated, we say, than a 2' or a 1' or simply a methyl. So again, our reaction is going to choose to proceed mostly through this carbocation intermediate. So I'm going to complete my reaction. We have our chloride anion hanging out over here, and it can attack this electron poor region, producing our product. Versus in this case, we had our chloride attack that portion of the molecule, the carbocation, to produce this product. Oops. I said it correctly, but I drew it wrong. There you go. So in this reaction, this will be your major product, and this will be your minor product. Again, because of this idea of Markovnikov regioselectivity and relative carbocation stability. That's it for hyperconjugation. Thank you.